Hi guys, welcome back to another video of me teaching, and today I have a number theory question for you guys. Well, why don't we just get into the question? A natural number is called a safe number if, except for the first and last digits, each digit is less than the average of the two adjacent digits. What's the largest safe number? Pretty long question, isn't it? And the question is, what's the largest safe number? Doesn't this seem kind of impossible to solve? Now, I'll just give you guys a simple example for a safe number. For example, 7213. You can check that if it's a safe number on your own. Well, it's talking about two adjacent digits, right? Won't that make us think that we should start in the middle of the number? Because if we start at an end, then there's not really adjacent digits to start with. So why don't we just call the middle number to be A? Right? That's a normal guess. But then, is it possible that the two adjacent digits right next to A are both less than A? No, of course not. So then, in all the cases, we might say this one's less than A, this one's greater than A, this one's equal to A, this one's greater than A, and this one's greater than A, and this one's greater than A. And all of these cases have one common property. At least one of these adjacent digits have to be greater than A. Without loss of generality, we can say that the left digit to A is greater than A. Say B. And I'll just write that statement down here. Without loss of generality, we assume that the left one, I just won't write that, you guys should know. We assume the left one, say B, is greater than A. And since these are all digits, there can't be like 1.1 or something. So then we know that B has to be greater than or equal to A plus 1. Right? This is equation 1. And from here, we know that A is less than or equal to B minus 1. Now, you guys might be wondering, why am I doing this? Well, I'm trying to prove that the amount of digits of this whole number can't go on to infinity. It just can't. So, what do we do now? Let's put another number, C. So, look at the requirement. Each digit is less than the average of the two adjacent digits. So B has to be less than A plus C divided by 2. Hence, we know that 2B is less than A plus C. So we know that A plus C is greater than 2B. Right? And from here, we know that A plus C is greater than or equal to 2B plus 1. And we do the same thing. We know that C is greater than or equal to 2B plus 1 minus A. And look what's in the brackets. A is less than or equal to B minus 1. So if we plug in B minus 1 into A, then this whole thing has to be greater than or equal to that, right? So this whole thing is still greater than or equal to 2B plus 1 minus bracket B minus 1. And this is equal to B plus 2, equation 2. Now, you guys might not notice the pattern yet, but after I show you D, you guys probably will. So, by using the same logic, we know that B plus D is greater than 2C. So, we know that B plus D is greater than or equal to 2C plus 1. So, D is greater than or equal to 2C plus 1 minus B. And from here, we know that B is less than or equal to C minus 2. So if we plug this in, then this whole thing is greater than or equal to 2c plus 1 minus bracket c minus 2. And this is equal to c plus 3. And this will make us equation 3. Let's see. B is greater than or equal to a plus 1. C is greater than or equal to b plus 2. And D is greater than or equal to c plus 3. I think you guys realize the pattern. So what if we have an E? E is greater than or equal to D plus 4. Is this possible? Well, let's check that out. So if D is greater than or equal to C plus 3, then this has to be greater than or equal to C plus 7. And C is greater than or equal to B plus 2, so this is greater than or equal to B plus 9. And this is already impossible. So we know that E cannot survive. So we only said that E cannot survive, right? But remember when I said that this digit can be equal to the middle digit? Well, yes, we haven't done that yet. So let's try to do that now. So A is still in the middle, but the one to the left is A again. And then we have B, right? So we know that A plus B is greater than 2A. So A plus B is greater than or equal to 2A plus 1. So we know that B is greater than or equal to A plus 1. Equation 1. And from here we know that A is less than or equal to B minus 1. Okay, let's do one more. C. Using the same logic, we know that A plus C is greater than 2B. So A plus C is greater than or equal to 2B plus 1. So C is greater than or equal to 2B plus 1 minus A. And A is less than or equal to B minus 1. So this whole thing is greater than or equal to 2B plus 1 minus bracket B minus 1. And this is equal to B plus 2. Look, it's the same pattern. So we know that D is greater than or equal to C plus 3. And we already proved that E is not possible. So this is the maximum case. So we know that this is also greater than or equal to, let's just try to prove that this is possible. C plus 3, C is greater than or equal to B plus 2, B plus 5, greater than or equal to A plus 6. Definitely possible. Well, since we already have this, and look at our first case. 3 digits to the left of A, 4 digits to the left of A. So that means that this case has to be greater than this case. Okay. Now, we've dealt with the ones to the left of A. What about to the right of A? Would you believe me if I told you that there could only be 3? So, didn't I say that in every single case, one of the digits has to be greater than A? Well, if we didn't have the ones to the right, but this is equal to. So the one adjacent to A, but on the right, has to be greater than A, correct? So this is greater, right? And we already proved in the first case that to the left of it, if this one is greater than the one in the middle, then there could only be 3. So that's why I said there could only be 3 here, since to the right, using the same logic, you'll get the same things. So we already proved that there has to be 8 digits. Now guys, we're so close to solving the question. Now, we know these connections, right? And I said that this, using the same logic, is the same, right? So, we know that x has to be greater than or equal to a plus 1, y greater than or equal to x plus 2 and z greater than or equal to y plus 3. Look, greater than or equal to x plus 5, greater than or equal to a plus 6. The same. So the digits of x, y, and z has to be the same as a, b, c, right? So let's try to deal with this first. Well, we know that the maximum digit of d has to be 9, right? Then c can be 6 because this is greater than or equal to, and so b can be 4, a can be 3. So we know that this part has to be 9, 6, 4, 3. And this is a as well, so it's 3. And remember when I said that x, y, and z have to be the same as a, b, and c? Yes. So 4, 6, 9. Done. So this is the final answer of this super cool number theory question. So thank you guys so much for watching, and if you enjoy my videos, please consider liking and subscribing. If you want to master something, teach it.